Hi, everybody. Welcome. Just getting our YouTube live stream started. And I should probably make sure my audio's on too while I'm at it. Yep, it is. So welcome and thanks so much for joining us. Let's see here. If you'll bear with me for just 1 second, I'm just going to make sure we are streaming, and we are. Awesome. Cool. Well, my name is Brooks Mitchell. I'm joined here by Claire Ratcliffe, and I see some familiar faces and names in the chat box. Not familiar faces, really, just familiar names. Hello, Ken. Good to see you. And so today we are going to be talking a lot about Mars. We're going to kind of be wrapping up our Universe of Stories 2019, webinar series. You guys are, we've given you the tools to get going, and you're going to take these tools and all these fun activities and facilitation tips and take them on and do great things this summer. We are absolutely sure of it. So somebody in the Q&A said something along the lines of, I can't find where to join audio. So the only thing you'll need, you're not going to be speaking at all in this webinar. You'll just be listening. If you want to interact, please do so in the chat box. It's just Claire and I in here. So our colleague Kellyanne LeConte, who just introduced herself, will be answering questions in the chat box, and we'll try to jump in whenever we're not facilitating an activity. So let's see a few other things. You are able to move your screen. So if you're like, I'm kind of tired of seeing Brooks and Claire, you can make us smaller, you can make us bigger, you can make the PowerPoint screen bigger. There's also some options. It should be like up in your top right area to where you could just kind of change what's going on and do some minor customization features. So I would encourage you all, please do play around with the Zoom infrastructure, if you will. That's not the word I'm looking for. With the Zoom system, you can't break anything, so don't worry. We can break some stuff, and as we have done on the past few webinars.
Happens.
Yeah, but yeah, any customization you do through the Zoom webinar shouldn't mess with us at all. So I'm going to take just a moment to look at our chat box. I think it's mostly just people introducing themselves. Hey, Doug, good to see you. Awesome. Cool. Well, we've got a good group of people. All right. If you'll bear with me just 1 second, I am just going to make sure. We got our eyes in the sky. Greg Mosshammer there in the chat box. He'll be interacting with him too, but he's telling me like, hey, your YouTube stream isn't going, so I'm just trying to make sure that we're all good to go. I think we're all, yep, good to go. Looks like it's streaming there. So Greg, if you want to say hello in the chat box, you'll be seeing a lot of him today. Also, Kellyanne, as I mentioned, she already said hello in the chat box. We've got Claire Ratcliffe right over here.
Hey, guys.
I am Brooks Mitchell. We're part of the professional development team with StarNet. We have a few different names for our organization and our projects. So just to make it easy, we'll say StarNet.
Yeah.
Yeah. Cool. And we got 2 Q&As already. Oh, great question. Aaron asked, I missed a webinar last week. Where can I find the archives? Greg, would you mind putting the webinar page in the chat box? And then Sarah Blackburn Lancaster asked, are all the other webinars archived? Yes, they are. All of our webinars, especially the public ones, are archived. You can find them on our StarNet YouTube channel and on starnetlibraries.com/resources/webinars. Not surprised that I know that. You can find them there as well. Cool. So let's go ahead and get started. It's hard. I see all the chats coming in. I want to answer them, but we'll never get started if we do that. So yeah, I already introduced us again. Also, we have Kellyanne LeConte in the chat box. She's going to be answering some questions as well. And just go over this agenda real quick. So we're going to start with a fun little silly poll question, of course, which is always fun to do. We'll have a more important poll question later. And actually, I'll go ahead and tell you what that last poll question is. It's about whether you would be able to attend summertime webinars. So traditionally, we know summertime is such a busy time for programs and the summer reading theme, really cool summer reading theme this year. We traditionally haven't done many webinars during the summer, and when we have, attendance has been, really low. So it's a poll question about whether you would actually have time to go and do that professional development piece and attend a webinar in the summertime. So just ruminate on that as you're watching these activities. So first poll question, okay, which of these would you rather go to? Let me launch the poll real quick. Which location would you most want to visit? Let me go ahead and launch it here. All right, so it should pop up on your screen or in the poll section of your toolbar, either at the bottom or at the top. You can vote. Let me give you guys 20 seconds or so.
Interesting.
So which one of these locations would you most want to visit?
Good questions,
Those
guys.
are good questions, I know. Let's say pre-explosion.
That might change some answers.
Yeah, it might. Let's see. All right. I'll give you guys like 10 more seconds. All right, let's share those. Okay, most people said the moon. Yeah, I'd probably agree to you just in terms of not wanting to be away from Earth for that long.
Yeah.
Mars is up there too.
Seems like the closer the better.
The closer the better, yeah.
The realer the better.
Let's see what the chat boxes say. Am I the only one who didn't know what Alderaan was? Ashley, no, that's okay. It's a Star Wars reference, and I'm not even the biggest Star Wars person. I mean, I like it, but I don't know all the planets like, by heart. But it's a planet in Star Wars. Ken says, I'm disappointed that we've left out Vulcan. That's funny. Yeah, it's true. It's definitely a trick question to some degree. All right. So we're going to talk just a little bit about, some of our normal resources that we do. Would you mind closing that? We got our one laptop hooked up to the TV, two laptops here. It's very much the control center in here. So our STEM activity clearinghouse, we talk about this all the time. It is where you can find all the activities that we're going to be talking about today. And Greg, if you haven't done this already, would you go ahead and drop the link bank into the chat box? So this link bank that Greg's going to drop into the chat box has been customized specifically for this webinar today. And it has a whole slew of different links that are going to be helpful to you, ones that we're going to be referencing today. I think I put like some Mars Insight social media pages and a lot of good stuff on there. So please, Greg looks like he just dropped it in. So yeah. So anyway, our STEM activity clearinghouse is kind of our central hub of STEM activities for you guys, in a library setting. They are cheap. They're easy to facilitate. There's a good review system. People like Doug, thank you, Doug, are going on there and leaving reviews to help other librarians facilitate those activities. So if you go to the clearinghouse and you do an activity and you're like, hey, this honestly did not work for me at my library, please leave a review. We're not offended by any means. We just want to help out the library world as much as possible. I don't know if I've mentioned that it's free yet, but all of our stuff is free and it's for you guys, the general public or library staff, I should say, to peruse and to use as much as you can. So yeah, we have a Universe of Stories collection on the STEM Activity Clearinghouse, and that kind of dovetails with what's in the manual a little bit, but then we've added some other activities that we think are just fun, easy, good space science activities that you could do at your library. So next we have our Summer of Space page, and this is just kind of our big summer initiative. It's not just Universe of Stories, and there's definitely a lot of correlation here, but it's also, we have some big NASA events and NASA anniversaries coming up, like the anniversary of the moon landing. Last year was the anniversary of Apollo 9? I forget. No, last year, excuse me, was the 60th anniversary of NASA in general. There we go. This summer is the anniversary of the Apollo 11 moon landing. So a lot of really big stuff going on this year. Let's see. Did I get that wrong, Ken? I just saw you post something in the chat box.
It's Apollo 11.
Yeah, Apollo 11 this year. In December, it was Apollo 9, I believe, where they got that. They were doing that first orbit around the moon and getting the first images of the Earth from the moon's orbit. So, yeah. Thanks. You had me sweating. Apollo 8. Thank you, Greg. That's what you get when you get a geologist leading a space science workshop. All right, or webinar. Sorry. Last thing I wanted to talk about was our, we just put in this really cool video for the NSF, the National Science Foundation STEM for All video showcase. So this is my shameless plug to get you all to go and vote for that video whenever it launches, which will be May 13th. So you can go ahead and put that STEM for All website in your bookmarks and then go and access it on May 13th. We'll send out another newsletter or we'll send out an update via email or something like that. So basically we did a video to talk about, thanks Sarah, to talk about our initiative to get libraries prepped for the 2019 summer reading theme. So part of this was we did a workshop in Wyoming. We've done a few different workshops all across the country, but we did one in Wyoming. I took some footage from that and then we added footage just that we have of patrons enjoying the library setting. And did a 3-minute little video kind of about why libraries are important and how we're getting them ready for to facilitate space science and STEM and everything like that. So I would encourage you to go check out the video on that bottom link, but also go and vote for it whenever the STEM for All video showcase happens, which is May 13th through May 20th.
Brooks did an awesome job. Definitely vote for us.
Definitely a team effort. Okay, cool, awesome. So I want to go ahead and jump in. I wanted to provide a little bit of like an update on the InSight mission. About this time last year, we did a webinar with Dr. Steve Lee here at the Space Science Institute. And technical problems aside, like my computer crashed as we started the webinar and it was all crazy. But then we had a great webinar. He talked about the InSight mission. We did some fun activities. And I just wanted to do a little update on the InSight mission. And I was like, you know, reading up, trying to sound smart and everything last night. And I was like, you know, it'd probably be more helpful for everybody if they just heard from the actual scientist on the mission. So I'm going to play a video real quick of some scientists talking about the mission. And this is just to kind of give you a background. And then we'll talk about what's been happening with the mission after that. Fingers crossed it plays.
Basic idea of InSight is to map out the deep structure of Mars. We know a lot about this.
Oh, no audio, I see. Let me try that again. Sorry.
The basic idea of InSight is to map out the deep structure of Mars. We know a lot about the surface of Mars. We know a lot about its atmosphere, even about its ionosphere, but we don't know very much about what goes on a mile below the surface. It's much less 2,000 miles below the surface down to the center. And this will be the first mission that's going to Mars specifically to investigate the deep inside of Mars.
We know that the Earth is habitable. We know that Mars is not. There might be something that we find out in terms of the structure of Mars versus the structure of Earth that maybe can help us understand why that is.
InSight carries a seismometer, which measures the seismic waves that have traveled through Mars from Mars quakes and maps out the deep interior structure of Mars.
We're going to also have a heat flow and physical properties probe, which will penetrate into the Mars surface about 5 meters or 16 feet to take the temperature of Mars.
And it has a radio science experiment, which uses the radio on the spacecraft to measure small variations in the wobble of Mars's pole to understand more about the structure and composition of the core.
InSight will be the first mission to pick instruments up off the deck of the lander and place them on the surface of Mars. I like to say that we're playing the claw game on Mars with no joystick. The seismometer needs to be installed in one place and basically not move in order to get the best seismic data.
We also have a wind and thermal shield that will then be placed on top of that seismometer to protect it further from the environment.
For the heat flow probe, HPQ, it also needs to sit in one place, take a while to hammer itself down into the ground and acquire the thermal measurements over a long period of time.
InSight is a mission to Mars, but it's much, much more than a Mars mission. In some sense, it's like a time machine. It's measuring the structure of Mars that was put in place 4.5 billion years ago. So we can go back and understand the processes that formed Mars just shortly after it was accreted from the solar nebula. By studying Mars, we'll be able to learn more about Earth, Venus, Mercury, even the Moon, even exoplanets around other stars.
All right. So I saw some people say they had some trouble hearing it. I tried to move the computer closer, but regardless, Greg, in the link bank, there is a direct link to the NASA multimedia page that you could insert in there as well. I hear you, just not the video. Huh, weird. Well, we'll try it again next time. I have one more video to show, and if it doesn't work, then so be it. So yes, check in your link bank for the Mars links for the different videos and multimedia, and you can find that there. But basically, to provide you an idea of what they're doing, they're measuring some of the interior of Mars. So we know a lot about the surface of Mars. We don't know as much about the actual interior. What did I just say? Yes, we know about the surface. We know about the atmosphere a decent amount. We don't know about the actual interior. And any seismometer reading, so like looking for earthquakes, or any type of ground shaking or vibration has been ruined in past missions because they didn't have a good way to adequately cover that seismometer. And now they're putting up this really great shield that goes over the seismometer that blocks wind and blocks other kind of noise, if you will. And so they're actually starting to, well, I don't want to get ahead of myself, but so we'll jump to the update. So it launched May 5th, 2018, basically in the first available launch window it had. It landed November 26, 2018. And when it landed, the first data arrived back to Earth about 16 minutes later. So there was, a good bit of, what's the word I'm looking for? Latency, maybe there. The communication is not quite immediate. And then over the next few weeks, it was just kind of like rolling out those different instruments. So you saw the seismometer that actually had to be pulled off the rover, or the lander, I should say, placed down, and then they had to grab that heat shield or wind shield and place that on top as well. They then had to put out this thermal gradient probe. So it's basically a long probe that they are digging into the ground to determine whether there's any temperature changes. And so they had to, knock that in. And I haven't heard any updates about the temperature gradient probe, but I did hear an update about the seismometer and some recent things they found out that we'll get into in just a minute. But I wanted to ask, did anybody in our audience today do programming, any type of programming for the InSight launch or the InSight landing? I see Ken did. What did you do, Ken? A landing party, very cool. And Christina, what all did you do? Well, so we got a couple of yeses. Oh, okay, landing party as well with crafts and the live feed. Yeah, so the live feed was pretty exciting. There's some fun videos in mission control of people celebrating when it's actually landing. These people did a silly little high five. It's fun. Hey, Jenny. Okay, awesome. Well, anyway, moving on, some of the discoveries or some of the observations it's made so far. I just did a quick little weather recap. It's if you go to the website, which I posted in the link bank of Mars weather, they talk about the different temperatures each day. So it looks like mostly the highs in this part of Mars are around 0 degrees Fahrenheit, lows in the negative 140s. It doesn't fluctuate too much from what I saw. Basically, like the highest high was 0 degrees and the lowest was -5 or something like that. But keep in mind, this is on the surface of Mars, of course, at the equator on a large flat plane. So these readings could be, not indicative of the whole planet. But yeah, so not the best weather to go and visit, but still somewhat habitable. Ken says pretty much like Montana. All right, so I was talking about that seismometer. A seismometer is going to measure ground readings, so like any seismic events that are happening underground. It's used to measure earthquakes here on Earth, North Dakota in April. Yeah, we just got snow last week, and then it's going to be 75 tomorrow. So anyway, and I hope you guys can hear this. I'll put the speaker up to the computer. But on April 6th, so InSight's whole, its big thing that it's looking for is whether there's been Mars quakes, what's the interior of Mars. And on April 6th, InSight actually recorded its first clear seismic event on Mars, which is really, really, really exciting. There's never been a confirmed Mars quake. One of the Viking probes maybe heard some stuff a while back, but again, there's so much wind, it was kind of hard to tell. So let me see if I can get this to play. All right, could you guys hear that? Let's see.
Kind of sounds like winds, yeah.
So we'll listen to it one more time and I'll tell you what's going on. I just wanted to make sure you guys could hear it. So these first 10 seconds or so is wind. So you're hearing wind right now. That's the Mars quake. Back to wind, the Mars quake is over. And then that is the robotic arm moving.
Wow.
Pretty cool. Well, thanks, Jennifer, for the heads up. Yeah, I don't know why the audio isn't coming through, but those are the only two things I had to show you for the most part. So no worries there. I wonder if we could just have that like audio playing in the background this whole webinar. It'd be kind of spooky.
Giant speakers in the background.
Yeah. So I'm going to take just a minute to check on the chats, make sure I haven't missed anything. It sounds like grumbling. Okay, looks pretty good so far. All right, awesome. So we have talked a little bit about the interior of Mars, or the fact that we're studying the interior of Mars. And I want to move on to a hands-on activity that talks about the interior of Mars. This is a food-based activity, so just a heads up. We can, if we have time, we can talk a little bit about maybe alternatives. And I think a good alternative to this one would be like modeling clay for the most part. But I'm interested to hear what you have to say. So this is called Recipe for a Planet, and this is the Mars edition. So there's one you can do with Earth, which would be good for Earth Day, but this one is specifically about Mars. And you know, I did this one for the webinar last year, but again, we had huge technical problems, so I was doing it on my laptop screen. So I thought it was we should do it again just for you all to actually see. And then Tamika, yes, the slides will be available later as well. Okay, so I'm going to, if you'll bear with me, I'm going to stop this video feed. I'm going to mute the audio, and then we're going to go over to our studio cam, or our hands-on activity cam real quick. So hey, everybody. Oops. Do you want to mute my computer? All right, here we go. So we are going to go ahead and get started on this. Sorry about that. And I have a Mars here that I've made already, and I just show you the finished product in case this one that I'm making turns out terrible. So basically what you need here are 2 Rice Krispie treats, some red icing, chocolate chips, red sprinkles in a little bag. Okay, so I got my red sprinkles here. I got my chocolate chips here. And then, yeah, that's about it. A plastic knife or a spoon, some plates, and some wet wipes are always a good idea as well. And Claire, can they hear me? Yeah. Okay, cool. Sorry, I just always want to make sure we can be heard. So again, what we're modeling here is the surface of Mars. And when you bite into it, there is a red interior. Now, scientists are, of course, figuring out more and more about the interior of Mars, specifically with missions like InSight. So this is an activity that could change as the InSight mission progresses, and we could learn more and more about the interior of Mars, and maybe you might have to make some modifications. But for now, it is a very fun and edible activity that you can do at your library. Okay, so for the Rice Krispie treats, you're gonna need 2 of them. And I've already flattened out one, okay? So you can see it's pretty flat and thin. And I have another one right here, and I just wanted to show you how to flatten these out. It's not hard by any means, but it's a little bit easier to do it this way. So just go ahead and squeeze it while it's in the container. And then at some point it's gonna pop, but you really wanna make sure you're getting it good and flat. All right, that should be good. We'll pop it out of its wrapper. Then I'm going to use this wrapper again just to flatten it out even more. It gives you specific instructions on how much to flatten it out. I find that really if you just flatten it out as much as you can while still keeping its integrity. So, maybe about 4 inches by 4 inches or 4 inches by 3 inches. It should be good. It's not going to be a perfect ball by any means. All right. All right, pretty good, pretty flat. And just peel it off, easier said than done. All right, so now we have 2 flat Rice Krispies. And on this flatter one over here, I'm gonna take this red icing, just regular red creamy decorator icing. It says icing consistency medium. I would go medium or stiff. You don't want soft or else it's going to be kind of hard to work with. This is just good enough to work with. All right, so we see it's in there. We'll take a little bit, take a decent sized ball. Again, maybe a little bit thicker icing would be better, but this will work. And we'll put it right in here. And this is the only tricky part, but it's also the fun, messy part too. If I've learned anything about librarians over the past 2 years, it's that you guys don't really mind a mess. Okay, so now we're just going to kind of ball it up like this over it. And you could, if you really wanted to, you could maybe do this with 1 Rice Krispie treat each, but I think it's just easier to do it with 2. All right. Let's see, what's Kendra say? Do you recommend eating your Mars after eating your Moon Oreo activity? I don't know. It might send kids into a tizzy if they have that much sugar at a program. All right, so this is not the most perfect ball. I'm glad I made one beforehand, but this will work. So now we have this Rice Krispie treat ball. You can see there's a little bit of Moon or Mars interior, some Martian magma poking out over the surface. The next thing we're gonna do, what did she say? You're sending them home after that anyway? Yeah, that's right. No caffeine, it should be okay. So what I'm doing here is basically I've got some red sprinkles in a bag, and I'm just moving this around to get as much coverage as I can. Of course, you're not going to get perfect coverage, but this, of course, models the exterior or the Martian surface, which we'll talk about in just a moment. Okay, so I have right now a Mars, an oddly shaped Mars, but still a Mars. It's got its red surface. And last thing I want to do is place some volcanoes on top of it. So Mars has a pretty volcanic history. It has the biggest volcano in the solar system. I'm not going to say in the universe, but in the solar system. So let's see. Let's get a little Olympus Mons right on there. All right. Now Mars has other volcanoes as well. So we're going to put a few more on there. All right. Perfect. And there we have our edible Mars. So what we've got here, again, we don't know a ton about the interior of Mars. We're learning more and more, but we're modeling the interior of Mars with that red icing. The exterior of Mars, it does have a lot of craters and different features. So you could say the Rice Krispie treat, if it's not perfect, it represents some of those features. We've rolled it around in red sprinkles because the Martian surface is red from all that oxidized iron. And then we have little volcanoes on the top as well. So this would be tasty. If I didn't have the rest of a webinar to lead, I would totally eat this right now. But I guess we better get on to the next activity. So if you'll bear with me, I'm going to mute this one. We're going to go back to our other view. All right. Does anybody have any particular experience with this activity? Does anybody have, let's see. Oh, great. So Heidi says this could be a little less expensive by using the colored sugar rather than the sprinkles. That's a great suggestion. It might even stick to the surface of your Mars a little bit better. It's probably going to depend on how, those are some old Rice Krispie treats in there. So I think that maybe would play into it a little bit, but that's a great idea. We did this last summer with the Earth and Moon as well. Hey, Elizabeth, how did you do the Moon? What did that look like? I know the Earth one uses a donut hole and helps you model the different layers of the interior of the Earth. Of course, we know more about the interior of the Earth. We used hot cocoa mix for the surface of the Moon. Oh, great. Yeah, so we have another activity. I don't want to go off too much of a tangent, but if you look up crater creations on the Clearinghouse, that's a great activity that models cratering on the Moon using cocoa powder. If you went to a NASA STEM workshop, you definitely know that activity. Very cool. Awesome. Well, if you have any other suggestions, throw them in the chat box. Would love to hear how you might modify that. Again, if you're not using food, if you work in a library that doesn't want to use food, and there's tons of reasons why you wouldn't want to use food, and tons of reasons why you would want to use food. So we definitely understand it's two different issues there at play. But you can do that with Play-Doh pretty well. any type of modeling clay, really. You could use a styrofoam ball. You would want to get a pretty coarse styrofoam ball, I feel like. Can you think of anything else? Pony beads, maybe, to model
Yeah,
the
any
volcanoes?
kind of like round objects that could perhaps be layered on top of each other.
Yeah. There's a really cool activity you can do to layer, to show the layers of the Earth using modeling clay. You make your different layers, you construct your Earth, and then you use floss to cut it in half so you can see a cross section. But to me, it's not as much of a library activity. There's a lot of heavy science there, and librarians, you guys excel at doing that hands-on exploration with the kids. So anyway, I'm going to move on to the next activity. Okay, Claire, I'm going to turn it over to you with My Trip to Mars.
All right, so this is a great game that kind of goes through the different steps of actually getting to Mars. And, that's a very complicated process. It can be dangerous. It can have all sorts of things that can go wrong. So this goes through a few of those scenarios. And it's a lot of fun. So for this, it's a pretty low cost activity. You need to make these posters, which I have behind us. You can see in the graphic here, the young girl has the posters. In this activity on the clearinghouse, you can print out all of these, all of the different materials that you would need to make these signs. So basically you would just need some dice, printouts of the poster scenarios, and if you want to put them on poster board, which we did not here, but in the image with the girl, you see that, then you may want 6 poster boards for the mission stages. And you can have fun with this. I know some people make big dice that kids can roll, and it's very exciting. Today, I'm just using a little tiny dice that you can get from any board game.
We've heard librarians say that like half the fun, well, maybe 25% of the fun is if you make a really big dice and have if you have a teenage advisory board and you're like, hey, we're doing this activity, can you guys make a really huge dice or dice? Singular? I think die is singular, dice is plural.
Mm-hmm.
That can be, it can be a whole lot of fun. Sorry.
Yeah, and there are instructions in the activities for how to make one of those dice if you want to make a big one. It'd be more fun than me today with my tiny dice. But the way I like to start this activity off is to have a little bit of a discussion where you're eliciting responses from your patrons. So asking questions like, A, why do we want to go to Mars? And getting people talking about that. What would you do on Mars? What are some of the reasons going to Mars would be difficult? And what help from Earth do the astronauts need to get to Mars? So those are some great leading questions that will be addressed later in the activity, but it just gets your patrons starting to think and just getting connected to the game. So I just wanted to, since you can't really see my posters very well behind us, I blew some up and just put them into these slides just so you can take a look. So there's step 1, which is just launching off of Earth and getting into space and getting to Mars. And so what you do, you have every team or every participant, however you want to break it up, start at step 1, and they're going to take the dice, give it a roll. And then if you could move to the next. Depending on what number they get on the dice, they will read that scenario. So let's say I rolled a 1. I get flight director.
Did you really roll a 1?
I did, amazingly enough. Some loaded dice here. So you get this scenario, and you lift up the flap. The weather is too stormy. Try again another day. Roll again. So this is really demonstrating that it's not super easy to get to Mars. In fact, in this game, it purposefully sets you up to fail about 50% of the time, which is actually an even smaller percentage of the failures that actual astronauts have to get there. But anyway, I'm going to try to roll again. Go ahead.
Okay.
All right, rolling again, and I got a 2.
Oh, you did.
I actually did get a 2.
Okay.
So our next scenario, ground control reports that the communication system is not working. I have to roll again. All right, let's see what I get this time. And I got a 3. All systems check out, and you're ready to go. Your launch is successful. Once you pass the launching phase, then you go on to stage 2, which is travel. And you would go through the same thing again, where you roll the dice, read the scenario. Another great thing about this activity is, as you can see in the scenario, it tells you all of the different people on Earth who are helping the astronauts in space. So for example, in this section here, I got Flight Activities Officer. And in the lesson plan, it goes through each of the different roles that people have here on Earth. And you can read out what their jobs are and really help your...
What are some of the...
Yeah, I'll read a few of them. So right here, we have Flight Activities Officer. So for that, this person plans and supports the astronauts' activities, procedures, and schedules. Let's see what this one was. Communication Officer serves as primary communicator between the flight control team on Earth and the astronauts. And we have a flight director, very important. The flight director leads the flight control team and is responsible for the overall mission. I don't know if I'd want that job.
Some weight on your shoulders.
Yeah, they make all the decisions regarding a safe flight. So they would be the one being like, nope, come on home, we're canceling, or proceed to the next thing. Yeah, so it's a lot of fun. It gets people up and moving around. And it can be, you know, people can get competitive or just have fun learning together.
Yeah, a good like kind of you are setting up stations, but you don't really have to facilitate that much.
Yeah, you really don't. Once you explain the rules and hand off the dice to your teams, you know, they kind of go through it just like playing an interactive board game.
Yeah. So you mean to tell me it's not just the astronauts that do all the work? There's other people?
Amazingly enough.
Wow, I had no idea.
It's a whole lot of people that can get humankind into space.
You're right. So I want to check the Q&A real quick. I thought we had a couple of, let's see. Okay, so Aaron's asking, could you use mini Rice Krispie treats for the Mars modeling activity? I don't see any reason why you couldn't scale it down if you wanted to use mini Rice Krispie treats. I'm not sure about how big they are. I'm thinking half or a third of the size. You would just have to scale everything down and probably get mini chocolate chips too. But yeah, I think from a material standpoint, mini Rice Krispie treats would work. Probably be easier to pound them out, you know? Mm-hmm. Christina asked, are there roles for the astronauts on the mission?
That's a really good question. So this activity does not go into the specific roles of the astronauts. It kind of lumps astronauts as like, the players are the astronauts, and it does not go into the specific roles. There are, in reality, all kinds of specified jobs for each astronaut. But this is mainly to talk about the people on Earth and just like all the complex teams and roles that people here on Earth have in a space mission.
Yeah, and it's really, I know when they select people, it's, you know, to be an astronaut, some are selected for flying skills, some are, they just had, I think, one of the first geologists maybe, or no, this was maybe with one of the later Apollo missions had the first geologist to go and visit the moon. And they said what a cool, unique perspective that person provided. So let's see. All right. Patty, you said we are piloting a new program for tweens, 8 to 13. Do you have any good activities that would work for tweens? This one might be the one that we're about to cover. Could be pretty good for tweens. It's talking about what life is, and I know that's a really big question, but I think Kellyanne just put something in the chat box. We have a whole tweens section on the Clearinghouse. So I would recommend you going and visiting the tweens category on the Clearinghouse.
Yeah, and I would say, yeah, this next activity we're going over has the potential to be modified for different age groups. And I'll kind of talk you through it. And I do think this is a great one for tweens.
Yeah.
All right, so before I hop onto the Elmo Cam, this activity, Search for Life, goes into one of humankind's like biggest curiosity. Is there life out there? Are we alone? And so scientists are grappling with this, and they're constantly on the search for other life forms out in space. And the search for new life starts by defining life. What is life? What differentiates something like a rock from something like a plant? You know, what is it that's a living thing? So if you could go to the next one, I want to put this back on you guys. How would you define a living thing? Put your answers and ideas in the chat box, and we'll just have a really quick discussion. But this is a great way to frame this activity and get people thinking.
Any object that breathes.
Okay, so something that breathes.
Okay.
Now, thinking about this, I think about a car. A car has car exhaust. A car could be considered breathing. Is a car alive? What else is there?
So
something that grows.
Grows or evolves.
Something that consumes or eats. Again, my car analogy, we put fuel into a car. A car is kind of eating. Needs food. Anything that eats, sleeps, breathes, grows. Something that produces energy and consume. Reproduces. There's another one. Something that has biological processes. Reproduces. Yeah, awesome. So the main point here, you guys are all correct.
Mm-hmm.
The main point here is there's not one single thing that can define something that's alive. So like I said, something that eats, I put fuel in my car every week, and it's burning through that energy. So in a way, my car is eating, and through the exhaust, in a way, it's breathing. But it's not capable of reproducing. It's not capable of making decisions on its own or having its own autonomy. Well, I guess smart cars nowadays, but yeah, but the point is, like, there's so many different boxes we have to check, and they all have to be checked.
Judith says, Judith, I think you probably had a science textbook up there or something, right? No, I'm just messing. She said, the ability to grow, reproduce, take in and use energy, excrete waste, respond to the environment, and possess an organized structure more complex than that of non-living things.
Awesome. Yeah. So all these different criteria. I really love what you said about respond to the environment.
Yeah.
That's another big one. My car can't respond to the environment the way that I can. Awesome. So yeah, a really great just starting point for this activity. And this is what scientists, they're still coming up with definitions of it. It's an ongoing debate. And so once the scientists have figured out, what is life, that helps them to determine what signs they're looking for. Yeah, so if you guys still have some thoughts, continue to throw them in the chat box and talk amongst yourselves. But I'm going to jump into the actual hands-on activity part. So give us just about 30 seconds. We're going to switch cameras, and I will be right back to you. All right, there we go. Okay, I'm going to clear out some of this stuff. So again, a very simple, low-cost activity. You can have participants working in groups, and the activity comes with these observation sheets. So this is why I think it's great for teens, because you can really have your patrons making observations and recording them. So what you need 3 clear cups that you're going to fill with a mixture of sand and sugar in each one. This first one I have here, this is just sand and sugar. The next one, I put in a crushed tablet, an Alka-Seltzer tablet. And the final one has the sand and sugar and also a little bit of yeast. So first you have your kids just look at these. They can smell them, look at it, from all angles, and just start recording their observations. And for younger patrons, you can,
I took the slide off.
Oh, okay. Sorry. For younger patrons, you can actually give them some words to choose from, squishy or grainy or things like that to help them think about what they're seeing. For your older kids, maybe you don't provide those words. You have them come up with things on their own, things that they've learned from school or from other experiences. So it can be adapted in different ways. Once you have these in front of your kids, and make sure you mix it all up, just take a spoon and mix it all up so the kids, they don't really know what's coming. And what you're going to do is after you make your observations, you're going to take some hot water and one at a time, just pour it into the cups and see what reactions happen. So this is my cup with just sand and sugar. And you want the water to be somewhat hot because you want it to be able to activate the yeast in the third cup. So now I'm pouring it into the cup that has Alka-Seltzer. You can kind of see what's happening there. It's bubbling, fizzing. There's some kind of chemical reaction happening there. And then finally into my cup with yeast. And after you fill these cups, you are going to have your kids, fill out some initial observations. But you're going to need to wait about 10 minutes for that yeast to really activate. And you don't tell your students that, but just have them wait. I can see this middle one here. I don't know if you guys can see it, but it's still bubbling away. Yeah, you are going to tell your students, let's wait 10 minutes. Let's see what's happening. We don't know what's happening with these bubbles. Maybe there's some kind of life underneath it. Oh, it looks like this third one over here, it's starting to bubble too.
Hey, Claire, do you want to move that third one? Move it between those two cups.
Sure. Oh, this
Oh,
one?
yeah, I was just trying to get a better view for everybody.
Oh, okay.
The yeast one.
Oh, yeah, so the yeast is starting to get very cloudy. Bubbles are coming up more and more. But basically, yeah, you'll just have your kids study these, watch them, make different observations, ask them for predictions, like what do you think is happening? All kinds of things like that. Now, you do want to wait a full 10 minutes to really get the full effect. So at this point, I'm actually going to pause on this activity and we'll come back to it later and we'll see what kinds of changes have taken place in 10 minutes. So I'm going to switch the camera back over to Brooks and we'll keep going.
All right, thank you, Claire. Awesome. So I wanted to just take a brief moment before we get into our last activity. Yeah, a word from our sponsors. Thanks, Doug. Thank you, NASA, by the way. So I should actually mention this is our work here at the Space Science Institute is funded by the National Science Foundation and NASA. So our big NASA project is called NASA at My Library, and it's allowing us to bring all this awesome free resources and professional development to you all. So you're right, Doug. I should have thanked my sponsors. You're right. Okay, so I wanted to ask this poll question. I know the format's really weird on the screen, but again, it's what I brought up earlier, thinking about whether you could attend a webinar during the, let's see, relaunching the poll. During the summertime. Okay, so again, it's like I just want to make sure that what we would offer to you all would be beneficial for you all. And I just know what we usually hear is like summertime is crazy. Don't plan anything for the summer. So anyway, we'll give you about 30 seconds to vote in the poll and then we'll take a look at the results. See. During Mondays, interesting, okay. Jacques, yeah, you're saying I could and would love to get new ideas or find out how certain activities work for others. If you haven't been to the Clearinghouse, Jacques, I would really encourage you to. We do have, gosh, over 85 reviews were left last year. You can tell we just sent a report in because I have that number off the top of my head. So people are leaving reviews and there's really helpful information there. Okay. Cool. I'm going to go ahead and launch these. So let me share the results with everybody. So actually, a surprising amount of people said they could attend summertime webinars. Unlikely, but there's a chance, probably came in second. And I couldn't attend, but I could view it later, or I would view it later. And then only 3 of you said not happening. I'm guessing you're the, yeah, specifically the school or the teenage or youth service programmer. Nobody said they were more likely to attend during the summer, which is kind of what I expected. So, okay, that's good information to know. Thank you, guys. There is, if you want to expand on that, you can say so in the chat box, but after this webinar is over, you should be redirected. The survey was acting a little weird. So you should be redirected to a survey, and then you could put in more information there based on that question. If you had a few more things to say, like, I could try to attend, but I wouldn't be able to. Let's see. Oh, you're okay. Somebody just said, is it Rael? I would have to watch it later. Summer is crazy here and we have a very small staff. So it's good feedback. Thank you, guys. All right. So our last activity of the day, we're doing okay on time, surprisingly, is going to be an activity called Mars Engineering. And this is a really open-ended activity. There's really basic parameters, and it's really a chance for you to make it your own, depending on your age group, depending on your size. And my favorite thing about this activity is depending on what you have in the closet that you are trying to get rid of. Oh, thank you, Heidi. Yes, we hope we can do some more for you. So this graphic I have on the screen right now is the engineering design process. Now there's a lot of different iterations of the engineering design process. Before I get ahead of myself, sorry, Greg, would you put the link for the Search for Life how-to video that we just uploaded today and the link and the chat box?
Yeah, so there's a really great how-to video for the activity I just demonstrated.
It literally came in our inbox this morning that the videographer had finished with it. So yeah, would definitely encourage you to check that out. But great job to you too, Claire. So anyway, back to the engineering design process. There's different iterations on this, and it's not, it's like the scientific method's pretty, I don't want to say cut and dry, but it is what it is. It's well defined. The engineering design process, I know you said at a recent job, you kind of used a different words.
Names, but the same concept.
Yeah, but so the big concept here is that you want your patrons, you kind of want them to fail. I hate to say that, but you want them to encounter some difficulties and have their experiment or their design not work well, because you want to, like, that reiteration is the big part of the engineering design process, okay? So if you do an engineering design process activity, please, please, please don't just give them 20 minutes and they get one design, one crack at it and they're done. Give your patrons more and more time to kind of, redesign, rethink about, retest, reprototype their activities or their design, so that they can kind of have that fulfilled experience of like, oh my gosh, I encountered a problem and I thought about it and I fixed that problem. There's always room for improvement. Even if they get it right the first time, you can say, okay, that's great, but try it again doing this, or try it again. Can you make it better? There's always some way to make something better. And there's tons of different engineering design process activities. I just chose this one because it's very Mars-centric focused, and that it's called Mars Engineering. So let's see. Oh yes, I forgot about this clever graphic I did.
Yeah, totally. I mean, you can talk to your students about, or your patrons about, think about astronauts, think about all of the Apollo missions. Did we make it to the moon on the first time? No, it took us 11 different missions plus so many more in this, in the lab before that, so you're constantly needing to reevaluate, redesign, and that's why this circle is just such a great model for.
Absolutely. You think about the, Apollo 13 and where they're making the carbon dioxide filter or something like that, or some type of filtration system with duct tape, and they're like, this is what we got to do it with. And it really does. It's a great cooperative style of learning too, a hands-on activity, an engineering design process hands-on activity. I would encourage you not to make it a competitive thing, just because not everybody responds well to that, but instead make it a collaborative thing. So there's tons. If you go to engineering activities on our clearinghouse, we have a whole slew of them. The one we are doing today, Mars Engineering, it's very open-ended, and my favorite thing about this activity is the materials list. And before you get like, oh my gosh, there's so much text on the screen. I know you're not supposed to actually read this all. This is all just to show you that this is like using recyclable materials, using things that you find in the recycling bin or in your cabinet, or in your office on your shelf that you haven't looked at in a year, like I did today when I was getting materials for this. So yeah, Christina, we need to put the square box into a round hole. So anyway, there's a slew of different materials that you can use for this activity. But the purpose is that you're creating a little rover, okay? So not a lander, but a rover, so it needs to be able to move, that can pick up and move and set a rock into a fake scientific instrument. So there are tiers you can do of this. If you're working with like 4 and 5-year-olds, I might say their goal is just to make a rover that can move, okay? If you're working for like 7 through 10, maybe you have them make a rover that can actually has a mechanism to pick up something, okay? If you're working with 10 to, I don't know, 31, you can have them create a rover that picks up something and moves that rock, okay? So we have done that. We have a list of, we have a big old bin of materials. I created a rover earlier this morning. I haven't tested it out. I don't really know if it's gonna work or not, but then we're gonna test that one out, and then Claire and I are gonna use a random box of materials to make our own rover. Does that sound good?
Sounds good. Let's
okay. Luckily, I have a really light rock. I have a piece of pumice, so that's what we're testing with. But cool, yeah, we're gonna move back over to that other camera real quick. We'll check on our Search for Life activity as well and see how that's going. And yeah, so bear with us for just 1 second. right. Let's see. Are we coming in? Yep. Audio's good. Coming in. So yeah, let's check on the search for life real quick. What do we see here?
All right. So what are some observations? This one never changed.
Yeah.
This one's bubbling much more slowly though. The bubbles are starting to slow. I see this one actually changed colors. This one in the middle.
Oh yeah. It looks very like milky kind of.
Yeah. And there are still bubbles coming up, sticking around. Interesting. It looks like there's a little piece starting to grow over here.
Yeah.
All right. So.
You smell them?
Yeah. What does that smell like?
Sand. Ooh, it smells like bread. Sand.
All right. Well, let's move these out of the way.
Let's move them way out of the way, away from the computers too. All right, cool. So guys, here is the rover. Well, first let's get our rock out. And here's the list of things that I'm going to let us build with. So here's our rock. Our goal again is to pick this up and to move this rock. Okay. So my rover, again, I created this with stuff that was on my shelf in my office. I did a little like some ping pong balls for the wheels. Okay. And they're attached the chassis, if you will. It's a word I've learned from a librarian correcting me on a webinar. I called it a chassis and she was like, no, it's a chassis or chassis. So it's these little tiny straws. I put like a toothpick in there, stuck the toothpick into some ping pong balls. So it does move. I can't say that it moves that well, but it does move. And then I did a spoon in the middle and a spoon up top connected with a straw. Yeah, we'll see. I don't know. I'm not that optimistic in it. So I was thinking, Claire, that we could, maybe be inspired by this.
Yeah,
and
do
then,
a little redesign.
Yeah. So let's see if I can pick this up. So the goal for me is not to use my hands to pick up the rock. I'm going to use the hands to use the spoon.
So close.
Oh, okay, okay. No, no, no. I tried this. Oh, okay, hold on. Let's see if I can wheel it over and move it to a different place.
Nice.
All right.
All right, that was good.
Hey, not bad.
It can be improved though.
I think it can definitely be improved. I got some stability issues here. I think if I loaded it too heavy, it would fall down. So let's see, Claire. I got our bag of materials. Again, this is just random stuff I kind of grabbed, knowing that I'd need a wheel, knowing that I'd need a scoop, but I have some styrofoam cups. I have some bottles here.
Ooh.
They're painted from a different activity. These might be good for something.
Yeah, I
got
have some
some
ideas for those.
Tiny cups, these little Dixie cups, a postcard. Hey, join the StarNet community. I got some Eclipse glasses. You remember these?
Yep.
Yep. Let's see. And then we got some straws, rubber bands, scissors, so on and so forth. So what are you thinking, Claire?
We have plenty to work with. I think you used the styrofoam cup as the body last time, and it seemed a little flimsy.
It was a little top heavy.
Yeah, these are a lot more like sturdy. Maybe we use a bottle for the body.
Okay.
Okay.
I like the way it's like a real car too. It's long.
Aerodynamic.
Yeah. So.
Okay, wheels.
Do you want to maybe work on the wheels, and I'll work on the scoop?
Okay. Yeah. Delegation. Great.
Yeah. So I'm thinking that this might be a good scoop. It's a little bit wider.
Yeah.
And with the spoon, it's like kind of lipped at the edge. It's kind of hard to pick it up. So I'm going to try this cardboard piece.
Okay, I'm going to try to use these little cups as wheels. I think since we have so many materials we could attach to it, I'm going to fashion some wheels for us. So.
Okay. Oh, we got some tape here too. Actually, we can use this tape as well.
Let's see.
All right, I'm going to cut one of these rubber bands. Nice, that looks good.
I think that'll work.
Yeah, maybe secure it on the inside.
Yeah, definitely we'll use that tape. Thank you. See, collaborative learning.
I am naturally a kind of a competitive person, but I think when I'm learning STEM, I like to be collaborative.
All right, I'm gonna use got this attached. I'm going to use a straw because then that can spin.
Oh, nice.
All
okay,
right.
Cool. Oh, and guys, I realize we're getting close to the top of the hour. If you do have to leave, we certainly understand. Greg, would you mind dropping the survey and the certificate of attendance in the chat box? So Greg is going to link you to the certificate of attendance. Okay, I got a little scoop right here. I think that might be good. Now, let's see. Do you have enough of these coffee stirrer things?
Yes, I'm
Okay.
done with them.
I think I'm going to use one for mine.
I'm
Put it-
almost done with one set of wheels.
Okay.
Yep, there's one set of wheels.
Nice. Okay. I'll wait to put them both on.
Okay. Do it pretty quick.
So I'm thinking I could like make a little lever up here to control this.
Ooh, yeah, little simple machine.
Yeah. Let's see.
Okay, same. As Brooke said before, it's really good to give your students and patrons a lot of time to do this. We're doing this really quickly right now, but I've seen people just get so into it and then frustrated if they have to be cut short. So, I mean, that's not always something you can control, but definitely I would have this activity be about an hour-long program.
That's a good idea, yeah.
And I think it's really fun at the end, as part of the design process and also the scientific method, have each group or each student share their design, brag about it, and then that way other people can learn and get ideas from everybody else. So that's a big part of the design challenge.
So
Okay, these are ready.
I think we're gonna do it. I want to be able to like maybe push it back if I need to.
Oh, okay.
Right. So let's do them towards the front. Do you want to put a piece of this tape just because it's easier to use?
Yep.
And then let's do one like right here. Okay. What do they say about teamwork? Makes the dream work, right?
Oh yeah. Teamwork don't seem work.
All right.
This is beautiful.
This
by
is.
the way.
Gonna hang it up somewhere. It's gonna go from random junk in my office to well. All right, so let's see.
Nice.
Hey, it moves. All right, okay,
Yeah,
all right, we're
okay.
moving along
Step
here.
one.
Let's see. What does it say? Make sure that it can spin. Yeah, you know, surprisingly, it actually can.
Seems sturdy.
Not surprisingly, because I doubt your ability, Claire.
Sure,
Sturdy because this
sure.
was actually my idea, so I do doubt my. Okay, let's see. So I'm thinking if I can scoop it up like this and then lift it, maybe.
Yeah, will it go? Should we
Let's
take
see.
this thing off?
Yeah, actually, that might be helpful.
Like a little button.
Yeah. All right, you gonna put the rock out?
All right. Testing is a big part of the design process.
Oh
too.
no! I might have to use the.
Use the wall, that's okay.
Oh no!
Well,
see, let's
this
try
one
again.
might require more iteration.
Yeah, that's okay. Hey, practicing what we preach here.
Right?
Oh no! All right, do you
Maybe-
guys have any suggestions in the chat box? If I go real fast, no. Let's see.
Someone suggested spreading out your design
Oh, I love that. Doug.
activities
Yeah.
over the course of 2 sessions.
It's like
Need a grabber inside. Make more of a scoop with the paper.
Mm,
Maybe if we like doubled up on,
the rubber bands.
yeah, or like this.
Oh yeah, yeah. Or here, let's just throw one over here. I'd probably be a lot more careful if we weren't wrapping up this webinar shortly.
Yeah.
Okay, let's see.
Oh,
Oh,
so close.
rats.
We need to be able to lift it.
I know. Yeah,
Higher.
it's not lifting quite like I thought it was gonna lift. That's all right.
Okay.
Ah!
Bend it up just a bit to make a scoop edge, says Sue.
Ooh.
Oh.
Well, on that note, I think it's time that we.
Yeah, so much potential here, but with time limitations, we're gonna switch back to the other camera. So give us.
that tip from the spoon.
Yeah.
All right. So guys, we're about 5 minutes over, so we'll kind of wrap things up. I did want to say, here's some other Mars activities. I had this from the last Mars PowerPoint we did, or webinar we did. So if you're looking for other ideas, Dunking the Planets deals with the density of different planets, how buoyant they would be. Fun activity. It does scale models of the planets, and they're represented by fruit and other foods, and you put them in water, and you find that some planets, even though they're really big, aren't really that dense. It's pretty cool. Mars Match is a fun activity. We thought about doing it this webinar, but we didn't quite have enough time, and boy, were we right about that. Where you're looking at different Earth terrestrial features and kind of matching them with the same type of feature on Mars. And let's see, build a space colony. It's going to be another fun kind of engineering activity, pretty open-ended as well, where you're building a space colony out of different recyclable materials. Strange New Planet is my absolute favorite activity, and I'll only say that about like 5 activities. So please check out Strange New Planet. It models different exploration of planets in our solar system and beyond, and just kind of how NASA and other space agencies make those decisions, whether they would go on to do other types of explorations and other types of missions. All right, so we do, if you're still around and you're able to, and you want to ask any questions, we will be happy to answer any. Let's see, where was there a link for the certificate? Yes, Greg, would you mind posting the certificate of attendance for the this webinar? Great, thank you.
And Adrian,
Never fill out a survey for the lunar one. I cleared it out, but I bet we could. Yes, Adrian, if you would like to fill out a survey for that one, we clear it out before each webinar. So I could just, if you'll email me afterwards, I'd be happy to let you fill out a survey. Or if you just want to give us some feedback, you can email that to me as well. Yes, Tamika, there is a survey for this webinar. Greg, if you want to go ahead and drop that in the chat box. And also when I exit out of the Zoom room, you all should be redirected to the survey as well. Lucy is asking, do I have a link with all the links? Yes, we do. Greg, if you wouldn't mind putting the link bank in the chat box as well. You're going to have sore fingers, Greg.
Thank you, Greg.
Yes, thank you. Let's see. I need a spoon for my grabber. Yep.
Yeah, I guess the spoon was a good one.
Hey,
you got it the first time with this. Maybe if we just used the spoon instead of the cardboard.
Yeah. We got a couple of hours left in the day. We can shut this down and just keep on. All right. Well, guys, for the sake of time, we'll probably go ahead and wrap things up. I did have if you have any more questions, please do put them in, and I'll check the Q&A as well. No, Billy, the survey, Greg put it in there. It's the SurveyMonkey one, so it's surveymonkey.com/r/starnet. It's at the top of the chat box, and you'll also be redirected when I close out. Yeah. All right. So last couple of things. Just remember, this is, we're super excited. This is kind of our last webinar to prep you guys for the Summer of Space and Universe of Stories. So I hope they've been helpful. If this is the first webinar you've attended of ours, we have like, 7 or 8 different Universe of Stories getting prepped, different activities, webinars. I would please go check out our YouTube page and our archived webinars page, because we have a ton of great webinars on there. I am kind of patting myself on the back there, but and our whole team. But yeah, definitely go check that out. And if you want to join our StarNet site, again, it's free. We don't blast you with emails. You get like 1 email a month with different free programming resources, different grant opportunities sometimes, different, yeah, it's just a great resource to have. Again, it comes about once a month. Thanks, Doug. Yes, Doug attended our Arizona workshop, our NASA STEM workshop, and then I think he's been on like almost every webinar since, Doug, so it is very much appreciated. Awesome. Well, that is it. Anything that you wanted to add, Claire?
No, just thank you guys so much. Good luck entering the summer. You're going to do awesome. And always the clearinghouse is there for you to peruse activities. So feel free to shoot myself or or Brooks an email if you have questions or just want more ideas.
Yeah, I'm putting my email there in the chat box right now. It's bmitchell@spacescience.org. Somebody else they said, can I get a copy of the certificate of attendance from a long ago or the lunar phases one? We have all those too. So if you're missing a certificate of attendance, let me know and I can get that sent over to you. I'll go ahead and put Claire's email in there as well. All right. So from us here at StarNet, good luck this summer. We will, of course, be online. We'll probably still offer a few different, I don't know if it'll be a webinar or what it'll look like, but we'll try to have some good, valuable resources with you all for you all this summer. So best of luck, everybody.
Bye, guys.